Hello everyone, this is the homework video number 220 for IM2. Alright, so number 20, it's asking you to sketch the triangle that make up the regular polygon below, and then find the area of each triangle and use to calculate the area of the regular polygon. Round your answer to the nearest tenth if necessary. Okay, so that's something that we need to keep that in mind. And question number 5 and 6 is extra credit and challenge problem because we haven't really learned it, though you can solve it if you do a little bit more thinking. All right, so number 1, what are we given? We are given, although this might not be clear, the 10.4 that we're given is the apothem length. Okay, so if you're given the apothem length, how can we figure out the area of these polygons? So first thing is count the number of sides, and I counted 7. And I should also draw all these radii, additional radii, so that I can see the triangle clearly. So now we're going to start by calculating the area of that triangle right here. What is the area of the triangle? Well, we know that apothem is 10.4. So apothem is 10.4 and the side length is 10. If that is 10, then this length is also 10. So to find the area of the triangle is always half times base times height. What is the base? Base is 10. And what is the height of this triangle? It's 10.4. And if I use the calculator, half times 10 is 5, 5 times 50.4 is 52. So I have just figured out the area of one of these triangles. And there are 7 identical triangles that make up this polygon, 7-sided polygon. So the area of the septagon that was the area of the triangle, is going to be 7 times 52. And if I multiply that, that should give me 364 unit square. Of course, the area unit is always unit square. All right, number 2. What this is, I counted as 9-sided polygon, and I am given the side length to be 8. That means this is going to be 8 units too, and apothem's length is provided as 11. So to figure out the area of this blue triangle is going to be half times base times height. Base is 8 and height is 11. So that's going to be 44 units square. So the area of this 9-sided polygon, so it's nanogon, is going to be 44 times 9, and that's going to be 396 units square. Moving on, number 3 is a triangle but we're given the apothem length, which is 1.3, and the side length is 4.6. So we can divide this up into 3 identical triangles as well. And so the area of the flat triangle, that's the little triangle, is going to be half times base times height, always. Base, what is the base of this triangle here? The base is the same as the side length, since we know this to be the regular polygon, so it's going to be half times 4.6 multiplied by height is 1.3. And if I use my calculator, I get 2.99 units squared. And so the area of the equilateral big triangle is going to be 3. There are 3 identical triangles that make up this big triangle. 3 times 2.99. And that is going to be approximately 9.0 unit square. Okay, oh, yeah, 9.0. Alright, so then number 4. I should start by drawing in my triangles. Like so. And so we have created 5 identical triangles that make up this pentagon. So area of the triangle is, well, the bottom or the height of this triangle is 8.1 and the side length is going to be 11.8. So area of the triangle is half times base, which is 11.8, times height, which is 8.1. And that is going to be, and I get that to be 47.79. So area of the pentagon is 47.79 times 5, because there are 5 identical triangles that make up this pentagon, and I get that to be 238.95. Now I need to round this to the 10th decimal place. That means this is the 100s, 10 ones, and this is 1/10 and 100th. That means I need to cut it off right here. But before I cut it off, I need to consider the next digit, which is 5. And since this is 5 or greater, I need to round this up by 1, and that rounds to 339.0 units square. Okay, so number 5 and 6 are challenge problems, so I am going to leave that for now. If I have time, I will go through that. But for now, let's go through number 7, 8, 9, 10. Alright, so we are trying to find the missing side length and round to the nearest 10th. So what are we given? All these are right angle triangles, so that means we can use our SOHCAHTOA. So sine is going to be opposite over hypotenuse. Cosine is going to be adjacent over hypotenuse, and TOA, tangent, is going to be opposite over adjacent. That's what SOHCAHTOA tells us, right? That's a mnemonic that's going to help you remember the sine, cosine, and tangent ratios. Okay, so what are the sides we are given relative to this 25 degrees angle that we're dealing with? This is adjacent. This is a leg, and this is the adjacent leg, and this is the hypotenuse leg, because this is across from the right angle. So which is the trig ratio that deals with adjacent and hypotenuse? That's cosine. So cosine of 25 degrees is equal to adjacent over hypotenuse, so that's x over 13. So that means x is, multiply both sides by 13. 13 times cosine of 25 degrees. So this is where you pull out your calculator and you do 13 times cosine of 25 degrees is going to be 11.78. 11.78. Now again, we need to cut it off at after 7. But before we do that, we need to consider the next digit. 8 is bigger than 5, so that means we need to round this up to 11.8. Round it to the 1 decimal place. Number 8. What are the sides relative to this angle here? This is my adjacent and hypotenuse again. Okay, so again, set up the equation. So cosine of 24 degrees is going to be adjacent, that's 14, divided by x. Okay, now because x, the variable x, is at the bottom, we need to multiply both sides by x first to bring the variable to the top. We can't have the variable at the bottom. And then from here, I also need to divide both sides by cosine of 24 degrees. Okay, to cancel this out so that you're left with just x on the left hand side. The x is 14 divided by cosine of 24 degrees. And that's when you pull out your calculator and you do 14 divided by cosine of 24, and that leaves me with 15.3. Now rounded to the nearest tenth. That means we are going to cut off after the digit, the 10th digit, which is 3. Before we do that, we need to consider the next digit 2, and 2 is less than 5, so that means we leave the 3 as it is. We do not round up, so it's going to be 15.3. Okay, now again, you should be checking to see, does your answer, does your length seem reasonable? If I plug 15.3, does that make sense? This length is 14, so it makes sense the hypotenuse will be slightly bigger. Okay, and that's what we have. Number 9. What are the sides that we're dealing with? Relative to this 49 degrees, this is my adjacent side, and this is my opposite side. So which is the trig ratio that deals with opposite and adjacent? That's tangent. So tangent of 49 degrees is opposite, which is x, over adjacent, which is 12. So x is going to be 12 multiplied by tangent of 49 degrees. And pull out your calculator. Okay, 12 times tangent of 49 degrees is going to be 13.8 rounded to the nearest tenth. Number 10. Okay, what are the angles that we're dealing with? This is the angle measure that we're given. And so this, the 15, although it's rotated, is across from the right angle, so that makes it the hypotenuse. And right next to it is the adjacent. So again, we have cosine of 72 degrees is adjacent, which is x, divided by 15. So x is going to be 15 times cosine of 72 degrees, and that leaves us with 15 times cosine of 72 degrees is 4.6. And again, cut off after the 6. Consider what the next digit is. 3 is less than 5, so we leave it the 10th digit as it is. So the correct answer is 4.6. Okay, so I have 2 minutes on this video recording, so I'm going to try to do number 5. Alright, again, I need to draw my triangles. The apothem length is given, but nothing else. We're only given the apothem length. Can we figure out the rest? Well, what do we know? We do know that this angle is going to be 360 divided by 3. So this angle is 120 degrees. So 120 degrees divided by 2, this angle here is going to be 60 degrees. Okay, so the purple angle is 120 degrees because that's going to be 360 divided by 3. So that's 120. And if that is 120, half of that is 60 degrees. So we know this triangle is going to have the length of 60 degrees. Now we need to figure out that if I call this x, this is the x from here to there, we can use our trig ratio to figure out what this x length is, because we know that 9/2 or 4.5 is the bottom or the other leg, which is so relative to the 60 degrees. Can you picture this triangle? What are the two sides? This will be the opposite sides, and 9.2 will be the adjacent side. So we have tangent of 60 degrees is opposite, which is x, divided by adjacent, which we know to be 4.5. Or 9/2 is same as 4.5. So then multiplying both sides by 4.5, I get x is equal to 4.5 times tangent of 60 degrees. And of course, if you remember the